Okay. Then if we have A and B in the alphabet set sigma, then some languages over sigma are pi, which is used to denote empty language. Okay, this is special case. Pi symbol used to denote empty language, means there are no strings. Then sigma, not sigma, this is epsilon. Epsilon is the language which contains only the empty string. These two are different. Students, please note, this is empty language, nothing is there, but this contains one symbol, that is epsilon. Okay, the language consisting of epsilon. Then L is equal to W. L is nothing but language. W belongs to sigma star, where length of W is less than 3. Okay, that means what? This is the language definition. Length of W is less than 3, means we can have 0 length, length 1, length 2, right? So now the example I have wrote here, L is equal to epsilon, string length 1, I have A, string length 1, I have B, string length 2, AA, AB, then what next? BB, I can have BA, I can have, right now, only that much. Here, less than 3, so string length 0, 1, 2. Can you tell me whether it is finite or infinite? When I say string length is less than 3, in alphabet set I am having only A and B. How many possible strings we can have? Anyone?
4.
How many? Here, epsilon 1. Then A and B, total 3. Then string length 2, AA, AB, BB and BA, 4, right? 4 plus 3, that is 7. So it is finite. Okay. As I told you, language can be finite or infinite. It is finite only when certain definition is given. Okay, sometimes if definition is given, we cannot say that it is finite. Okay, next example I will explain you. For example, this one. W begins with B. Is there any restriction on the length? Is there any restriction? No. Just they will tell us as W begins with B. So how many strings we can form? Infinite number of strings can be formed for this particular language. So this language is infinite, right? Begins with B, so I can't have just A. Okay, so B, and one more thing, whether epsilon belongs to this language. Epsilon means nothing. Whether epsilon belongs? No, because a condition is given, W begins with B. So my first string is B, then BA, then BB, BAAB, okay, like that. Any length, so we can have string length having 10 or 100 or 1000 or more. So it is infinite. Now go through the third example. Hash means number. Number of B in W is equal to 2. Okay. You can have 2 B's wherever, in the beginning or at the end or in between. Okay. So strings are BB. See here, one B is in the beginning, one B is at the end. Here, 2 B's together from the beginning itself. Here, again, one B is here, one B is here. Whether it is finite or infinite? Anyone?
Infinite.
Infinite. Okay, the only condition is number of B is equal to 2. There is no restriction on the length. Next one, each A is followed by exactly 2 B's. Means if there are A's, then it must be followed by exactly 2 B's. Here, I didn't write the example over there. Understood now? Each A, if A is there, then it is followed by exactly 2 B's. We cannot have more than 2 B's. But we can have ABB. Once again, ABB we can have. Each A, see, you have to understand the question clearly. Each A is followed by exactly 2 B's. Clear? Okay. Then last one, W does not begin with the A, means it can begin with the B. Later we can have A, BA, BAA we can have, but ABB or just A we cannot have. Okay, clear. This is example for the language. Now, some problems are there. I will dictate at the end. Sigma star, very important. What is sigma star? We are going to use this sigma star everywhere. Okay. Sigma star is defined as a set of possible strings that can be formed from the alphabet sigma. Star means 0 or more. Please remember this sigma star, A star, B star, etc. It is required for the next semester subject also. Sigma star means, or power star means 0 or more. Combination or occurrence, how many times? 0 or more. Sigma star itself is a language. It contains infinite number of strings. Clear no? 0 or more means there is no upper bound, so it is always infinite. So what we can say is sigma star is countably infinite. There is one small theorem before that example. Sigma star example. Better to note down this. Sigma is given by A comma B. If anything you feel important, you can note down. Okay. I can't say each and everything to note down. Okay. I won't say also. If you feel it is important for you or to remember later, you can note down. Sigma is A comma B. Sigma star is given by epsilon means nothing, 0. Then A, B, then A is concatenated with AA, any combination. Okay, so you can consider any combination AA, AB, BA, BB, then string length 3, AAA, AAB, and so on. BBA, BBAB, many combinations. So it is infinite. String length 4, 5, 6, etc. up to no upper bound. So this is how to write sigma star. Now write the sigma star for, okay, one small work for you now. Problem, write sigma star for sigma is equal to 0 comma A. It's not 0 comma 1, I say 0 comma A. This 1 minute I will give you. Write sigma star for sigma is equal to 0 comma A. Don't write all strings, just 4 or 5 is enough. Then put dot dot dot. Anyone? Should I mention? Nikita Rao. Okay, you write. I will call the attendance now. Answer your attendance. Unmute your mic and respond. Narration.
Present, ma'am.
Navina.
Yes, ma'am.
Okay. Nayana.
Present, ma'am.
Nikita.
Present, ma'am.
Nikita Rao.
Present, ma'am.
Nishant. Nishant not available.
Yes, ma'am.
Pavan.
Yes, ma'am.
Prajwal.
Yes, ma'am.
Pramodini.
Yes, ma'am.
Pranita. Pranita, right? Pratiksha. Oh, Pratiksha is there, no?
Yes, ma'am.
Okay, Pratiksha J.
Present, ma'am.
Priyanka Prabhu.
Present, ma'am.
Prithvi Prabhu.
Present, ma'am.
Rashmita.
Present, ma'am.
Rohit Kumar. Rohit Kumar. Fatimat. Fatima, Shreyas,
Yes, ma'am.
Sadakesha,
Yes, ma'am.
Samiksha,
Present, ma'am.
Sampath Kumar,
Yes, ma'am.
Sampath Kumar PL, Sandeep Kumar, Sanjay, Sanjay VS, Santosh, Santosh M, Satvika,
Present, ma'am.
Sharat,
Present, ma'am.
Sharvari,
Ma'am.
Shivani, Shivani P,
Yes, ma'am.
next Shravan, Sija,
Present, ma'am.
Shreya, Shreya G. Rai,
Present, ma'am.
Shrikant, Shrikant, Smita, Suraj,
Yes, ma'am.
Saujanya,
Yes, ma'am.
Sri Lakshmi,
Yes, ma'am.
Sudarshan, Sudarshan, Sumant,
Yes, ma'am.
Sumant Rai,
Present, ma'am.
Abhishek,
Yes, ma'am.
Vaishnavi,
Yes, ma'am.
Vaishnavi VB,
Yes, ma'am.
Vasudha,
Yes, ma'am.
Vijeta,
Present, ma'am.
Vijita,
Yes, ma'am.
Vikram,
Yes, ma'am.
Yashasvi,
Present, ma'am.
Yashasvi,
Present,
Akshata,
ma'am.
Yashasvi
Present,
is
ma'am.
present. Okay, okay. Nikit,
Yes, ma'am.
Mohammed,
Yes, ma'am.
Prithviraj,
Yes, ma'am.
Vijay Lakshmi.
Present, ma'am.
Okay. Answer is ready. Sigma star for 0, A. Priyanka Prabhu, can you answer?
Sigma.
Okay.
Sorry, ma'am. Epsilon.
Ah,
0
ah,
A
okay.
0 A
Ah,
A00.
okay. Enough. Okay, like that. Any combination, any length you can form. That is about sigma star. Now, techniques for defining languages. Already we know how to define language, but still there are two techniques. One is set notation, another one is characteristic function. We are concentrating on this set notation. Okay, characteristic function rarely used and not important as well. Okay, set notation means it is writing the notation for the language like this. Within the flower bracket, you need to write L is equal to W. W means a string. Okay, please remember we are referring a string generally by W only. So W belongs to sigma star. Where you have to read this one parallel line is where description of the W means where string length is less than 3 or A is preceded by something like that we have seen in the previous slide, isn't it? So that is nothing but description of W. This is one method. Here now L is equal to W belongs to sigma star. This part is same for all the language definition. Then where is the difference? Difference is description of W. Actually, the strings belonging to the language are described over here, this part. In another way, instead of sigma star, we can write the alphabet which are there in sigma directly, A, comma, B, comma, C star. Here, if you write sigma here, initially we need to denote sigma. What is sigma? Sigma is equal to A, comma, B. Initially, we have to denote. Then we need to write first method, or in the second method, directly in the place of sigma, mention the alphabet A, comma, B, comma, C star, description of the W. This is the very common method and important notation for defining language. Notation can vary, but must precisely define. Means we must be able to understand this definition or the description. That's why it must be meaningful. Okay, another one is characteristic function notation. We are defining the language in terms of true or false relation. True for every element, false for everything else. Means strings belonging to the language, it should return true. Strings do not belong to the language, it should return false. Okay, don't concentrate on the second one. Only the first one we are going to use in the entire subject. Example, as per our description, see here, L is equal to X. Okay, instead of W, they wrote X, but better to use W only, as I told you earlier. Belongs to A, comma, B, where all A's precede all B's. Okay, all A's precede all B's. If there exists A, then it should precede all B's. Now, example, A, B, because there are two A's, they are preceded by B. It is belonging to the language. A, B, B. There are three A's. All A's will come before B. It is also there. Here also two A's, then three B's. It is there in language L. What about A, B, A? It is not there in L because you can see one more A over here. After B, we cannot have any A's. So it is not there in the language L. Similarly, here B, A. B is preceded by A. No, not that. That is not the case. A must be precede A. So this is not there. A, B, C is not there. Why? A, B is fine. A is preceded by B, but one extra character C is there in the string, but it is not defined. L is given by the alphabet set A and B only. Here there is existence of C, so it is not there in L. Then there is a question, what about epsilon? Whether epsilon is there? Yes, because there is a star. Now you understood the meaning of star, I think. Star means 0 or more. So we don't have any A or don't have any B. So epsilon is there. Just A. Whether it is there? Yes, answer is yes, because it is just A. We can have A. If we have A's and B's, then only the condition exists. Okay, please try to understand the definition. All A's precede all B's. So this condition holds good only when there are A's and B's. But here only A. Okay, fine. We can have A, we can have just BB. That's also we can have. Because of this star, combination of any string formed by just A or B or A and B. So only A's we can have, only B's we can have. But if there are A's and B's, then this condition should hold good. Understood now? Can you give an English description for this one? Okay, this is for you. I don't have answer for this. I mean, written answer I don't have. Let me explain the problem definition now. X is a string. Okay, are you following? Students, following me? Okay, X is a string. Then there exists Y. Okay, there exists Y means a substring. Belongs to A, comma B star means we have A and B in the string language. Okay, where X is equal to YA. Means what? How we can write English description for this? Like English description means like this. See previous example. All A's precede all B's. This is the English description for the language. So for this, how will you write English description? Strings of A's and B's ending with A. Okay, I will just tell you because this is the first problem, English description problem. No, strings of A's and B's or just strings ending with A. Okay, see last one A is there. No, so what we can say, strings ending with A. If I say AY, how will you change description? AY, same problem. If I say AY, then strings starting with the A. Okay, now if I say AYA, how will you write?
String that starts and ends with A.
Yeah, starting with A as well as ending with A. Now understood, right? If such type of description is given, then you need to convert description into English description. Okay, sometimes it may not be possible to write the English description into this particular form. For example, this one, all A's precede all B's. We cannot write properly this type of expression for this. That's why we can use either English description or such type of description. Which one we can feel easy, we can write. And you need to understand both. Okay. Problem definition may be given using English description or may be given using such type of description. Examples, already we have gone through this one. Sigma is A comma B, then L is equal to W. See, both type of description have been given over here. See, what about this one? Parallel lines, two parallel lines. W is written with two parallel lines. Length of W is less than 5. Okay. Then this one is our English description. W begins with the B. This one we can convert into other way, isn't it? There exists Y belongs to A comma B star, like this. Okay. Exactly, you can write like this. Yes, there exists Y belongs to A comma B star, where X is equal to, how to write? For this, W begins with B, you write BY. Correct now? Isn't it? We can write BY, where Y is the combination of A's and B's. Third one, each A is followed by exactly two B's. Can you give some example strings for this? Each A is followed by exactly two B's. First one I can say ABB. Later, when there is A, it is followed by exactly two B. So I can have ABB, then some B's, okay, BB. Once again, ABB I can have. If A is there, then it is followed by exactly two B's. Last one, W does not begin with the A, means it should begin with the B. Okay, now problems. Take down. Which strings belong to the following languages? First problem, A power n, where n is greater than or equal to 0. I'll mention the name just to think. Half minute I will give you. First problem, A power n, where it is replication, n is greater than or equal to 0. First string, Sharat CS. Can you tell me the answer? Others also solve the problem. Where is Sharat? Not there. Answer the attendance, no. But now, where are you? Prajwal. Are you there? Pawan?
Epsilon.
Okay, first one is epsilon. Letter
A.
A. Next one,
A square.
A square, but you have to write AA.
A
Okay,
into A.
AA, then 3A, 4A, like that you have to write. Okay,
Yes.
please don't write square or power 3 in the language definition. Fine. Okay, next one, B into A power 2n, where n is greater than or equal to 0, which is the first string. Shivani P.
Epsilon.
Epsilon, whether it belongs, just a thing. N is replaced by 0. Then what happens? There is B always. Did you observe?
BAA.
Yeah, yes.
Yes,
First,
yes,
okay.
ma'am.
First one is just B because N is replaced with the 0. Clear? First one is
Okay.
B. Next one BAA. That is also fine.
BAA.
Yeah. Third one B.
BAAA.
Yes. Not
A
3A,
into
4
A.
A's. 4 A's because
Okay.
2N. Okay. Clear.
Mm.
Next B followed by 6 A's. B followed by 8
I
A's. Like that. Okay. Put dot dot dot. Last example. D power N A power N. N is greater than or equal to 0. You should answer. Vaishnavi VB.
Absolute.
Yeah. Epsilon.
Then BA,
BA. Then
BBAA,
yes. BBAA. Then BB.
BBE,
Okay. 3B, 3A. Okay. 4B, 4A. Like that. Okay. Enough. All of you have to solve this one. Okay. Answer is already told. Okay. Next, let us move. Enumeration. Enumeration means in general it is list, right? No, listing. So enumeration means list all the strings in a language. There are two types. Okay, so listing all the strings in a language, like we have listed in the previous one, right? No, B power n, A power n, then BA, BB, AA, like that. So listing. But there are two ways. What are those two ways? One is arbitrary order. In any order we can write. Like if it is A power n, okay, just A power n I will take. Then 2 A's I will write first, AA. Then 4 A's. Then just I will write 1 A. Then I will write epsilon. Okay, that is arbitrary order. In any order, we can write the strings belonging to a language. Clear now? Arbitrary order means any order. But second way, another type, and it is more useful, which is called as lexicographic order. What do you mean by lexicographic order? It is important. We are going to solve the problem. So if you want, you can note down. There are two conditions. Shortest first. This is the first condition you need to apply. Shortest string first, and within a length dictionary order or alphabetical order we have to follow. Okay, clear? Shortest first means epsilon first, then string length 1, string length 2, string length 3. If we are going to write a string of string length 3, then we should follow alphabetical order. If I have A and B in the alphabet set, for the string length 2, I need to write AA first. Here, I cannot write AB or BB first. AA first, letter, which one I should write? Alphabetical order, A and B. AA, AB, then BAB. Okay, you understood now. Okay, now directly we will go for the problem solution. This one, take down answers I will give you. Okay, but think first, write the question. Write the lexicographic enumeration or write. Okay, question is given here. Write first 6 or 7 strings which are lexicographically enumerated for the following languages. right? First 6 or 7 strings which are lexicographically enumerated for the following languages. Shall I move the slide?
Yes.
First one. W belongs to A, comma B whole star where length of W is E1. Means string length 0. String length 0 is considered as E1. 0, 2, 4, 6, like that. Right now, strings having length 0 means which is the first string? Epsilon. Right now, string length 0 is epsilon. Later, string length 2. String length 2 in alphabetical order. As you told in the previous explanation, AA, AB,
Baby.
BA, BB. Next, what happens? String length 4, no? For string length 4, obviously we have 4 A's. Correct, no? Then 3A, 1B. Later, AA, BA. Means first 2 A's are same. Okay. See, if you can interpret like this, string length 4 means first 2 letters are AA always. Next letters, it is combination of previous 4, AA, BB, C. First 2 A's, same for all the strings having length 4 now. Okay. Only for these 4. Then append AA, AB, BA, BB. Okay. Here now, like that. Next letters we can have A followed by B, AJ. Okay, like that. Understood? No? How to write in the alphabetical order. String length 4. Next problem, second problem, you will solve by yourself. W belongs to A, comma B. All A's precede all B's. Remember, if there are A's and B's, then only this condition holds good. We can have epsilon. We can have just a string length 1, string length 2, string length 3, like that. Just analyze the answer epsilon. Okay, null string, just A, just B. Then string length 2, AA I can have, AB, all because A is preceded by this B. Whether I can have BA, whether I can have BA? No, because according to this question, all A's precede all B's. Then, are you following, students? Enumeration, lexicographic enumeration. First you have to
Yes, ma'am.
consider, okay, first you have to consider string length, later lexicographic order. Here string length 3, which is the first string? All 3 A's. Okay, then A, B. Here this is fine. B, 2 A's are preceded by 1 B. Next, BA we cannot have because all A's must precede all B. So next string will be A, B, B. Then comes B, B, B. Okay, next, etc. String length 4. Third example. Are you writing the answer? Are you copying? Yes or no? Respond.
Yes, we are writing.
In the notes, you can expect only theoretical explanation. Problem solution, we are not going to give. So, when there is a problem, you have to take down on itself. Third one, will you try yourself? W is A, comma B. What is mod operation first? Length of W, mod 3 is equal to 0. Anyone?
Epsilon, AAA,
Ah,
AAB, ABA,
okay,
ABB,
okay.
BA. So
Okay, later on. Okay, after which string length will come after 3?
After 3, 6.
6. Next we have 6. When a string length is divided by 3, you should get the remainder 0. Mod operation. Okay. Many are there, so I just put a dot dot dot. AB, ABA, ABB, then BAA, BAB, BBA, BBB, etc. Next directly comes string length 6. Now down. Over now, this one, just 5 minutes. One small theorem is there, that one I will complete. Okay. Cardinality of a language. Cardinality of a language means number of strings in the language. Okay. Understood? If we have some 10 strings, then cardinality is 10. Number of strings in the language. Here, for example, what is the cardinality of the language 1? Please don't consider this dot dot, only this one. What is the cardinality? 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is the cardinality. It is denoted by length of L, parallel lines. Smallest language. Which is the smallest language always over any alphabet? It is pi, means nothing. Language consisting nothing is always the smallest language with the cardinality 0. Which is the largest one? Any idea? Sigma star. It is given here. Why largest is sigma star? Because infinite number of strings are there in sigma star. Can a language be uncountable? Let us see the answer. There is a small theorem. Countably infinite. Why the word countably infinite? That is because if there is some restriction, then a language can be countable. If there is no restriction, then it is always infinite. So we will use the word countably infinite. If sigma is not equal to pi, means some languages are there, some strings are there in the language, then it is countably infinite. We can prove like this one. It is done by using lexicographical enumeration. We know about lexicographic enumeration now. Enumerate all the strings of length 0, length 1, length 2, okay, according to string length. Then within the given length, follow the alphabetical order. This enumeration is infinite. We have already seen, right now. So there is no longest string in sigma star. When no longest string means we can't say which is the longest string in sigma star. But my point, there is no longest string mean, it doesn't mean that there is no answer. If there is an answer, like we cannot say which is the largest string in the sigma star. Since there exists an infinite enumeration of sigma star, we can say that a language is countably infinite. Okay, that is. And then how many languages are there? We cannot count at all. So the word uncountably infinite. How many languages? We can't say. So it is always infinite, called as uncountably infinite. Proved by power set. You know the power set, right? If I have, set theory power set. If I have 3 elements in a set, then power set contains 2 to the power 3, right? Means 8. That basic point you know, right? Yes or no?
Yes.
Power set. Okay. So set of languages defined on sigma is power set. But we know that sigma star is infinite. Sigma star is infinite. Then what happens for power set of sigma star? Is it able to count, or whether we can count power set? Sigma star's power set, we can't, obviously. So there are infinite number of languages. Okay. Functions on the languages, let us study in the next class. Fine. Maybe for 1 minute. Problems are there. I will give you one. This one. Take down this exercise. Consider the, just tell me the answer. That is also fine. Consider the language L is equal to 1 power n, 2 power n. N is greater than 0. Is the string 1 to 2 in L? Rashmita K, can you answer me? 1 power n and 2 power n. Means number of ones and number of twos are the same. The string 1 to 2, is it having the same number of ones and twos?
No.
No. So it is not there in the language. What about this one? L1 is given by, okay, this one you can't solve now because concatenation of the language is not over. Okay, this one you take down. Let's L1, L2, concatenation again. Okay, fine, enough. Okay, next class, let us study about concatenation, union, etc. This one. Functions on the languages. This one we will study in the next class. Okay, students, have a nice day. Any doubts? If
No,
you
ma'am.
have any, no. If you have any doubts, you can ask. Okay. In between also you can ask.